Alright, today we are going to tackle the whole idea of naming compounds. And it's not horribly difficult, but at the start it seems extremely complicated. So we're going to try to take this a step at a time and hit each step really thoroughly. First thing that we've got to know is the difference between a compound and a molecule. Right? So far we have done a lot of things with molecules. We've talked a lot about molecules, and a molecule is any time that we have a covalently bonded, things are covalently bonded together. So, you know, water. They're all covalent bonds. They're very polar covalent bonds, hydrogen bonding between them and everything like that, as we've learned. But they're all covalent, so this is a molecule. Carbon dioxide, nonpolar molecule, London dispersion forces there. Also a molecule. Methane, CH4 is a molecule. Ammonia is a molecule. Okay, all of those are molecules. Compounds are when we have ionic bonds. Okay, any ionic bonds in a compound, in a group of atoms, make it ionic. Even if there are some covalent ones there, as long as there's one ionic, we're going to call it a compound, not a molecule anymore. And the naming changes from that. Okay, so something like MgOH, which we have looked at, OH2, would be because Mg is a metal and O and H are both nonmetals. This is a ionic bond, okay, ionic, and so it is a compound, not a molecule anymore. All right? The way that we're going to name this, we are going to always start by naming the metal. So in that last one, MgOH, right, our metal is this guy, so we're just going to say magnesium. Okay? So you will have to know your metals. The second part gets a little bit more complex, and we've got to come back and touch back on the metals, and we'll do that in a few minutes here. But the second part gets a little bit more complicated, and I'm going to go to the easiest one. Metals names don't change. The non-metals names do. Okay, so we're going to switch this up a little bit. We're going to go MgCl2 to make it a little bit simpler. We'll come back to the OH thing in just a bit. But this is chlorine. We've looked at it, we've played with it, we eat it every day. When it is part of, in our salt, don't eat just chlorine, that's bad for you. But when you are talking about a compound, the non-metal changes its name. Okay, if it is all by its lonesome, if it's like chlorine here, yeah, there are two of them, but there's just chlorine there, we simply take the end part and we change it from whatever it is to an IDE. Okay, so this is magnesium, so MgCl2 is magnesium chloride. Okay? Hopefully that makes sense. And when we're looking at it backwards and somebody gives us the word magnesium chloride, well, we know that chlorine goes with -1 because it has 7 valence electrons. It wants 8, so it gains 1 more. We know that magnesium has 2 valence electrons it wants to get, so it has 2 plus. Well, we figure out a way to make that equal 0. Okay, and so we have to times that by 2, so we times that by 2, MgCl2. Okay, magnesium chloride. All right, so let's look at, let's not do iron. Iron's got some other things that we've got to worry about. Let's, rubidium, okay, with an N. And we've got to figure out what the ratio is, what numbers are going to go here, what numbers are going to go here. Let's start with that. Nitrogen has 5 valence electrons. Okay, so it has a -3 charge. It's going to gain 3. Rubidium has 1 valence electron, so we've got to make this make 0. So 3 there, 1 there, so we're looking at 3N. Okay, we'd take our metal and we just name him. And then we look at our nonmetal, in this case it's nitrogen. Okay, and we change the ending to IDE, so it is rubidium nitride. DE. Make sure I get that right. Okay. Now, when we were looking at molecules, we said we had certain functional groups. We said we had an alcohol, we had a ketone. Same thing happens with compounds, where we have certain things that clump up together all the time. We see them all the time, and so we've actually named them. So let's look at a couple of these. Our first one is going to be a hydroxide. Oxide. And that is just going to be an OH. All right. Charge on this is going to be a -1, which is very easy to determine because this is going to be a -2, this is going to be a +1, so that equals -1. So if you need to, you can work it out that way, but hydroxide is always a -1 charge. Okay. Then another one that we are going to have is nitrate. And this one looks a little bit funny, or a lot bit funny. Notice here, this is weird for us, that the nitrogen has 4 bonds and no lone pairs, right? This can happen. What that ends up doing is nitrogen wants 5 valence electrons. With 4 bonds, it means that it only has 4, so we're going to say that it has a +1 charge. Remember, electrons are negatively charged, so this is negative and this is negative, so I end up being 1 higher than I should. Okay, so my nitrogen actually has a plus charge here. My oxygens each want 2 bonds, and they each only have 1 bond, so they both have these negatives to account for that. These two cancel out, and so this nitrate has a negative charge overall. I know, really confusing, right? Anyway, so it's always going, let's make it a little bit simpler. Nitrate, that's what it is, that's why it's that, is NO3, always has a negative charge. Okay, first one is why it does. This is just nuts and bolts of it, boom, right there. It is NO3, negative charge. Next guy is carbonate. And he looks almost exactly like nitrate, but notice carbon wants 4 bonds. He has 4 bonds, he wants 4 bonds, so he doesn't have a positive charge. So I've got a negative here on both my oxygens, so this guy has a -2 charge, because again, both the oxygen want 2 bonds, they don't have those 2 bonds, so I've got a -2 charge. So carbonate is my next one. He is, oops, forgot my E, CO3, and he has a 2- charge. Okay, our next one is chromate, and he is CrO4, 2-. Next one is sulfate, SO4, 2-. And phosphate, PO4, 3-. Okay. Now these functional groups have their own name because, you know, we went from molecules to compounds. So we're going to go from functional groups, and we're going to call these polyatomic anions. Okay, big word, not as confusing as it could be. Anions, we know, are negative ions. Okay, positive thing to kill a cat, so anions are negative. So it's something that has gained electrons. Okay, atomic, well, okay, it's atoms. Poly, many. So many atoms that are negatively charged. And if you go back through, we've got many atoms here, negatively charged, negatively charged, negatively charged, okay? So that's all that we mean when we're talking about polyatomic anions. So let's do a couple of examples, and then we'll end this one, and we'll come back to the metals and that part of it. And let's go with barium nitrate. Okay, well, there's its name. I just gave you its name. Okay, remember, we don't do anything to the name of the metal, and then we name the polyatomic anion. If that's what I gave you, you would write barium and nitrate. What numbers should we put here, and how should we do that? Well, barium likes to be 2+. Okay, nitrate, we said, is always 1-. So to make that equal 0, I need to have 2 of my nitrates. So I'm going to put this in parentheses, put a 2 down there, and leave that the barium alone, because that means that it's 1, and then this is how it would be written. Okay?